Yeah?
Yeah.
Relax now. House rules are clear.
Yeah,
Yep.
it's clear.
You can start your announcements.
I don't think we have any
Yeah,
attendees
I
yet.
will start. I will start it. Just
Nobody.
checking is there any participants whether I can check or not. Yep. Mic test 1, 2, 3. Everybody hear me?
Yes, yes, yes.
Okay. A very good evening to all guests, participants, and presenters here today. Welcome to SPM revision seminar by Help University on the subject of physics tonight. Before we move on to our revision, there are few house rules for us all to follow. Firstly, for those who are not presenting, please mute your mics. And if you do not have any questions or interactions with the speaker, please do not display your webcam videos throughout the session. This is to minimize distractions during the forum. Secondly, for anyone who would like to ask a question to the speaker, please post your questions on the chat box so that the moderator can read them out during the Q&A session. Or you can raise your hand virtually just by clicking the hand icon below. Thirdly, at the end of our event, we'll be organizing a career and course counseling session for any attendees and guests who are interested in any course or in Help University itself. To them, please do remain in this meeting room and the marketing counselors will attend to you. With that said, let us move to our revision seminar now. Let me introduce our speaker for today. He is an expert in physics and is from the Department of Foundation. His name is Mr. Eilham bin Muhammad Osman, and he will be our speaker for physics subject tonight. Mr. Eilham, the floor is up to you.
Hello, hello, hello everyone, and welcome to our SPM revision class. Okay, my name is Mr. Muhammad Eilham, and I am from Health Matriculation Center from the Foundation Department of Health University. Okay, and today we are going to do SPM revision. The format for this revision is actually this is going to be a 10-week session. Okay, each week we are going to have one class every Monday. Okay, each week you are going to be given a link on the Microsoft Teams. So if you have got the link for this week, okay, for the next week we are going to give you a new link. Okay, you cannot use the link that have been provided today for the next session. Okay, it's not you cannot really recycle it. Okay, so that's for a little bit of introduction on how this session is going to happen. Okay. All right, so let me get started with the idea of the weeks. Okay, so for physics, sorry. All right, For physics, we are going to have every Monday from 8 to 9 p.m. We are going to have our revision class. So on the first 5 weeks, we are going to cover Form 4 chapters. And for the other 5 weeks, we are going to cover Form 5 chapters. Okay, so for our first week, this is the topic that we are going to cover, Introduction to Physics. For the second week, we are going to cover force and motion. Third week, force and pressure. Fourth week is heat. And the fifth one is light. Okay, so in this first 5 weeks, this is for Form 4. Okay, moving for the next one is Form 5. Form 5, we are going to learn about wave, electricity, electromagnetism. Okay, this one will be on week 6, 7, and 8. And then we are going to move to electronic and radioactivity on week 9 and 10. Okay, so these are the dates. So make sure you take note on these dates so that you won't miss any particular topics that you might be interested in or you might want to go for, right? Okay, so this is for the schedule. All right, so let's go to our actual revision. Okay. All right. So most of the time when we are learning physics, okay, we are going to have this introduction to physics. Okay, in any particular level, you have this introduction part. All right, I have seen in SPM and then in matriculation and also in degree level, you are going to have this introduction. So some students actually ask me, is it really necessary for us to learn this introduction part? I will tell them that it is very, very important. Okay, I have seen students even in degree level, they are not able to do unit conversion. Okay, so this chapter, even though this one is very, very easy, or most people actually consider this as easy, but then don't try to take it for granted. Okay, this is the one question that I can guarantee you. Okay, this chapter. All right, sorry. This one chapter, I can guarantee you will always come out in your SPM, and I can guarantee you that this will come out in question, okay, physics. Okay, paper 1, question number 1. I can guarantee you this will happen every year. Okay. All right. So sometimes this question might come in in paper 2. Okay, so paper 1. Okay, this question might come in paper 2. Paper 2 usually will involve measurement if this come. Okay, so this will involve measurement of some sort. Okay, but for paper 1, this one is the easy part. Okay, if you are a student who are struggling with physics, then you don't want to miss out these marks. Okay, this is literally a free marks for you. All right, and most of the teacher that I met, they say that this question is a warm-up question. Okay, warm-up question. So if you don't have the proper warm-up, then if you open up your question paper and then you actually find the first question to be hard, and that will actually falls to the consequent questions also. The whole paper is going to be hard for you. Okay, mentally it will be hard for you. So we want to actually make this, okay, I actually want to make this easier for you. So we are going to cover the basic first. Okay, all right, so let me erase this. Okay, get my eraser. All right, so when we are talking about physics, okay, when we're talking about physics, physics is the measure of something, okay? Physics is a measure of physical quantity. Okay, this should be very much, you can actually, physical quantity, you can actually understand this by now, okay? All right, so what is this physical quantity that we want to observe or measure, okay? So there are several things that we measure. Okay, those things we call as base quantity and also derived quantity. All right, derived quantity. So these are the two simplest type of physical quantity available for you. Okay, so let's go to the base quantity. You can see over here. Base quantity, this is a unit that cannot be obtained from any other unit. Okay, this is a physical quantity that cannot be obtained from any other quantity. Okay, so what does this mean? In other words, okay, in my own terms, I will say that this thing, okay, this simply says that when we have, okay, when we have the, sorry, okay, this simply says that when we have, okay, so this simply says that when we have a base unit, okay, base unit or base quantity, okay, this base quantity are being obtained straight from our measuring device. Okay, this is straight from measuring device. Okay, so what such example do we have? Okay, so these 7 are the key things that you need to know. Okay, you have length, mass, time, thermodynamic temperature, electrical current, and also amount of substances, luminous intensity. Okay, so take a look at each of these base units. If you are measuring length, you are going to take that length from a ruler, for example. Okay, you measure something, okay, you have an object, you have a pen, okay, and then you take a ruler, you measure the length, you straight away take that from the ruler. Okay, that is what we call as base quantity. Okay, next we have mass, of course. Mass, you stand on a weighing scale and then you observe the mass, you jot down, you take out the value. That's what we call as base quantity, mass as a base quantity. Time is also the same. Time, basically, we take a stopwatch or a watch of any kind, and then you record the time and you take it. Okay, that's a base quantity. For thermodynamic temperature, okay, so for temperature, we have a thermometer. Thermometer is used to measure your heat, okay, what's your temperature is. All right, and then next we have electrical current. Okay, so these three, okay, this might be new for your level, okay, but it's important for you to know all of them because there are only 7 base quantity. Okay, so electrical current, this one is obtained by using an ammeter. Okay, you have a circuit. So in order for you to measure the circuit's electrical current, you need to have an ammeter plug in onto your circuit and you can read the readings. Okay, all right. The next one is amount of substances. This one is used mainly in chemistry. Okay, this one, if you are studying chemistry, then you should know what a mole is. All right, and the next one is called as luminous intensity. Okay, so this one, some of you might know it as how bright an object is. Okay, the idea is that luminous intensity is the measure of how bright something is. Okay, some sort of light source is. All right, okay. So from this base quantity, then we can create something entirely new called as derived unit or derived quantity. Okay, so what are derived quantity? Derived quantity is defined as this. Okay, is obtained by either multiplication or division of base quantity. Okay, so let me highlight this one. Okay, so the key important thing that you need to remember about derived unit or derived quantity is that it cannot exist by itself. Okay, it need to have base quantity in order for derived quantity to exist. Okay, All right, so for example, I have over here several examples. Let me give you one that I actually very much like. Okay, so the formula, the example for derived quantity that I very much like is, okay, let me get this. Okay, so volume is defined as, okay, let's define volume. Volume is defined by length multiply with breadth multiply with the height. Okay, so let's say if you have a cube, okay, let's say we have a cube over here. All right. Okay, this is not really a cube, but okay, never mind. So this is supposedly a cube. We have over here our length L. This one is breadth, or sometimes we call it as width. Okay, width, W-I-D-T-H, width. And we also have the height. Okay, this part is the height. Okay, so in order for us to obtain volume, we need to multiply each and every one of these quantity. Okay, the measurement, right? But if you look over here, length, breadth, and height, they actually all refers to one same unit. Okay, length is actually length. Okay, length is simply length. Breadth is also some type of length. Height is also some type of length. So when we are defining volume, okay, in dimension, okay, the dimension of volume, volume can be said to be made from length multiply with length multiply with length. And this is multiplication. You can see over there from the definition, multiplication and or, okay, sorry, this is or, multiplication or division. So we have length multiply with length multiply with length. Okay, so this is going to be cube of length. Okay, length cube. All right, so this is a famous example for derived unit. Okay, what is derived unit? Derived unit is something that you obtain by multiplication or division, or mathematical operation of some sort. All right. Okay, another example for derived unit is this one. I believe density. Everyone should have learned about density at some level. Okay, density is obtained by mass divided with volume. Okay, this is the formula for density. And what is mass? Mass is a basic quantity. We have talked about mass just now. Mass is over here. Mass, this is mass. Mass is a basic quantity. So you can see we have mass. The dimension is m. Okay, and then divided by volume. What's the dimension for volume? Volume consists of length multiply length, which is length cube. All right, length cube. So these are the dimension. This is the simplest unit, the base unit. This is the length. Length is also the simplest unit. So if the question in SPM asks you, which is density, okay, it's, sorry, is density, okay, something is happening. Is density derived unit, derived quantity? Or is it base quantity? Which one is it? Okay, the answer is derived quantity. Why is density a derived quantity? Because it consists of mass and also volume. What is the actual base quantity that make up density? That is mass and length. All right. Okay, so I hope you get the idea, that idea, all right? Okay. And next one, okay, this one is the famous one. I really like to tease my students with this one. When we are talking about physics, we cannot move away from a unit. Okay, there is also a saying that says math in math, right? sorry. Okay, in math, you are going to play with number, but in physics, you are going to play with unit. So this is our playground. Okay, all right. So conversion, unit conversion happens in two different manners. The first one is when you have different unit. Okay, I might want to write that one down. Okay, conversion happen when you have different unit or you can also have conversion when you have different prefixes. Okay, so what does different unit mean? What this one actually talks about? Okay, you might realize in your daily life that we are used to SI unit. Okay, something called as SI unit. What is SI unit? The example is meter, kilogram, and then we also have second. Okay, meter, kilogram, and second. This one is very, very standard one. In Malaysia, we use this one quite a lot. But if, let's say, you manage to move to US, okay, let's say you move to US. In US, they don't use meter. Okay, in US, they prefer foot or miles, for example. Okay, they don't measure distance in kilometer. No, they don't. They use miles. And when they are measuring mass, they don't use kilogram. They use pound. Okay, and then time. Well, time you have very, very much different. You have hour, you have minutes, and you have seconds. So that one is pretty much. I think you got the idea already. Okay, but then this difference. Okay, they are different in unit themselves. So as a student, you need to know how to convert from one unit to the other. Okay, all right. So let's say you are telling yourself, well, I don't actually know how to convert. Okay, that's okay. We have some exercise. Okay, I have prepared some exercise for you to try. Okay. So over here, I have this one is prefixes. I am going to teach you through step by step how to actually convert from one prefix to the other prefixes. Okay, all right. So let's start with this one. We have 2.31 kilometer. We want to change this to millimeter. How we actually do this? Okay. So the first step, okay, always remember this. When you have something new, okay, when you have something, sorry, this one, all right. Okay, the first one, right. Okay, so the first one, when you have a prefixes, change to a base first. Okay, change to a base first. Okay, so what does this mean? Okay, look at what we want to convert. We want to convert 2.31 kilometer to millimeter. So 2.31 kilometer. We want to convert it to millimeter. So the base over there should be meter. So first, you need to change to meter. And after you have changed to meter, then you move to millimeter. Okay, take a step one by one. You start with kilometer, you move to meter, and then you move to millimeter. That way it will be easier. Okay, so we have 2.31 kilometer. You know that 1 kilometer, okay, 1 kilometer is equal to 1,000 meter. All right, you know this. So 2.31 kilometer would be 2,310 meter. Okay, you just multiply with 1,000. Okay, all right. So multiply with 1,000. And then at here, 2310 meter, you want to change this to millimeter. How do you do that? Okay, so in order for you to change from base unit to your preferred unit, okay, take a look at the power of your unit. Okay, milli. This is a millimeter. So let's look over here. What is milli? Okay, what is milli? Milli is this one, 10 to the power of negative 3. Okay, 10 to the power of negative 3. So in order for you to measure this, okay, convert this, sorry, you need to multiply with 2310, multiply with 10 to the power of negative 3. Okay, all right. But when you multiply with 10 to the power of negative 3, you need to also multiply with 10 to the power of 3. Okay, all right. So what's the purpose of us doing this? The purpose of us doing this, if you see, this multiply with 10 to the power of negative 3, multiply with 10 to the power of 3, this is actually 1. This is actually 1. 10 to the power of negative 3 times 10 to the power of 3 is 1. You can put out your calculator, you can calculate that, okay? You can check on your own. This is 1. So what we are doing right now is we are taking 2310 meter, we are multiplying it with 1. Okay, all right. So now as we multiplying this with 1, 10 to the power of 3, we are going to rearrange this a little bit. Okay, so I put 10 to the power of 3 at the front, 10 to the power of negative 3 over here. All right, so what's the purpose of me doing this? Okay, we defined just now 10 to the power of negative 3. This is called as milli. Okay, this is called as milli. So as this is milli, I can just change from this number, I can change them into words. So I will have 2310 multiply with 10 to the power of 3 millimeter. Okay, all right. So this, okay, this is the conversion, 2310 times 10 to the power of 3. Or, okay, if you want it to be in scientific notation, you can still multiply this with, okay, 2.310 multiply with 10 to the power of 3 multiply with 10 to the power of 3. Okay, so you can just put on your calculator this value, 2310 times 10 to the power of 3, and then you take out in this form, 2.310. Okay, make sure you get a decimal point like this. Okay, and then, okay, on your calculator, you should be able to get 2.31 times 10 to the power of 6 millimeter. Okay, this should be your final answer in scientific notation. All right, okay. So the key idea is to change from one unit, change to a base unit, and then change to a preferred unit. Okay, all right. Okay, next we are going to look at this one more question. Okay, this one, instead of prefixes, we have okay, conversion from different unit. Okay, different unit. All right, let me take a draw again. Okay, so now we are going to convert 1.8 miles to kilometer. Okay, so 1.8 miles, I want to convert it to kilometer. Miles to kilometers. So how do I do this? Okay, so my preferred method, okay, you might have learned something else, but my preferred method is just to multiply this with 1 mile. Okay, and the top part will be 1.609 kilometer. Okay, you can see over here, this is mile, this is mile. The unit will actually cancel out. Okay, the unit will cancel out. And then this will be, the left one will be 1.8, Okay, sorry. 1.8 multiplied with 1.609 kilometer. And what are the unit? Sorry, the unit left is kilometer. And the final answer will be, let me see, 1.8 times 1.609 is 2.8962. Okay, 2.8. Right. $2.8962. Kilometer. Okay, so the key idea over here is to use this unit conversion. You have the conversion rate given. Okay, in most cases, you are going to have your conversion rate given. So what you need to do is you just take it, you decide which one you want to eliminate and which one you want to keep. Okay, for this case, I want to keep a kilometer. I want to eliminate miles. So I cross mile, I just keep kilometer. Okay, all right. Okay, and this one, student got confused about this one. So I will also talk about this one. We want to convert 100 centimeters square into meters square. So we need to mention 1 meter is 100 centimeter. Okay, I want to mention this. Okay, so how do I convert 100 centimeters square to meter square? Again, the same method as the top one, the previous one, 100 centimeter square. Okay, and then I want to eliminate centimeter, so I put centimeter down. 100 centimeter, 1 meter. Okay, so I will eliminate one. Okay, the centimeter unit will be eliminated once. So I need to multiply again with 1 meter over 100 centimeter. Okay, so it will be twice eliminated. Okay, all right. So most students that I encounter, when they are converting from 100 centimeter square to, okay, when they are converting 100 centimeter square to meter square, what they do is they just divide by 100. Okay, that is wrong. Divide by 100, that is wrong. Because you actually divide by 100 twice. Okay, divide by 100 twice over here. Okay, right. So, okay, so we are going to have 100 over here. And then over here, I will have 1 meter divided by 100. And then over here, I will have 1 meter divided by 100. Okay, so this can cancel. So I'm going to be left with 1 meter times, okay, 1 meter times 1 meter divided by 100. And that will be 0.01 meter square. Okay, you can see over here the meter unit multiplied with the meter unit, they actually make meter square unit. Okay, this is the beauty of doing this kind of conversion. Instead of just remembering multiply with 100, multiply with 1000, okay, if you remember it that way, you won't really see what is happening. If you are doing it like this, okay, you are going to see that the unit actually cancels off. Okay, just like this one, mile cancel with mile, centimeter square cancel with centimeter, cancel with centimeter. So you are left with only meter square. Okay, all right, so these are the tips that I can give you. When you are changing from base, okay, when you are changing from different prefixes, change to a standard base and then change to a preferred base, preferred prefixes. But when the unit are different, just use the conversion rate. Okay, in most cases, SPM question will give you the conversion rate. Okay, and this one I don't put the 100 cm because I believe you should have known by now that 1 meter is 100 centimeter. Okay, all right. Okay, this is for the second part. And the third part, okay, this one is also quite famous. This one is the difference between vector and scalar. Okay, vector and scalar. So when we are talking about physics, when we are doing measurement, this is the form of measurement that we are going to make. Okay, we have a quantity measured, any quantity that you are measuring. You are going to have a magnitude, meaning how big or how small something is, and the preferred unit. Okay, for example, let's say you are entering a building. Okay, usually you will encounter the guard. The guard will take your temperature, body temperature. So the quantity measured over there is body temperature. Okay, this is the physical quantity that we are measuring. And then the guard will say, okay, adik, 36.5. Okay, 36.5 degrees Celsius. Okay, what does this mean? It means that on the scale from 0 to 100, I have temperature of 36.5. This is the magnitude. Okay, this is the magnitude. And degree Celsius over there, this is the unit. Okay, this is the unit. If somehow I go to US, okay, this degree Celsius is not going to be used. US people, they prefer to use degree Fahrenheit. Okay, and degree Fahrenheit, they have a slightly bigger amount of value, bigger amount of magnitude compared to our degree Celsius. Okay, just want for you to have a little bit of idea. Okay, so this is the example that I gave. Okay, body temperature over here. Okay, so when we are talking about this magnitude, we are going to move towards something much more crucial, which is the difference between a scalar quantity and a vector quantity. Okay, scalar and also vector quantity. Okay, so what is meant by scalar quantity? Scalar quantity is defined as quantity that have only magnitude. Okay, it only have a certain range, right? But when we are talking about vector, we have magnitude and also direction. Okay, it is important for you to know the difference between scalar and vector because this one is also quite frequent in SPM question 1. Okay, question 1, paper 1, quite frequent. Okay, so what is an example for this situation? Okay, so let's say you go jogging. Okay, let's say you go jogging. When you're jogging and you finish, you go talk to your mom. Okay, mom, today I managed to jog 2 kilometers. Okay, let's say you just managed to jog 2 kilometers. Okay, that is 2 kilometers for you. But let's say I come to your house. Okay, I want to go to your house. All right, I call you. Okay, and I ask you, hey, how can I go to your house? And you say, my house is 2 kilometers from you. Okay, does that make any sense? Okay, that doesn't really make any sense because right now the 2 kilometers, even though 2 kilometers refers to length, but there are no context in that conversation. Okay, so instead what you can do is you can say, oh, my house is 2 kilometers from Health University, for example. Okay, so in that sense, I know, okay, if I go to a health building, if I went and see a health building, I know it's 2 kilometers. But does that help? Does that help me in going to your house? It still didn't help. Okay, what I would need is a proper direction. Okay, my house is 2 kilometers east of Health University, or my house is 2 kilometers north of Health University. Okay, so in that two different cases, we are measuring the same thing. We are measuring a physical quantity called as length, but they bring different contexts. One is scalar and one is vector. Okay, if you go for a higher level, if you go for a matriculation, for example, if you went to our matriculation center, you are going to learn that one is called as distance, and the other one is called as displacement. Okay, this one is covered in chapter 2, but it was covered quite, it's not really that well in-depth covered. So you might want to understand what actually is happening. Okay, one is called distance because it only carries magnitude. The other one is called as displacement because it carries magnitude and direction. Okay, all right. So another example that I can think of, okay, this one is for you to think, is speed, okay, and the other one is velocity. This one is also covered in chapter 2, so just want to refresh you. Chapter 2, form 4, okay. So one is speed and one is velocity. Okay, so I want to ask you, which one is scalar and which one is vector? Okay, so what is speed actually? If you think about it, speed is just a measure of how fast an object is moving. Okay, speed is how fast an object is moving. Let's say you are on a highway. Your mom calls you, and then you say, I am driving at 80 km per hour. 80 km per hour. Okay, this is your speed. But okay, when we are talking about velocity, velocity have direction. Okay, velocity have direction. Most of the time when we are talking about velocity, we are going to give it in positive or negative value. So let's say I am moving at negative 80 km per hour. What does that mean? That means that I am moving backward 80 km per hour. But if I am moving positive 80 km per hour, okay, positive kilometer per hour, this means that I'm moving forward. One is forward, one is backward. Okay, or sometimes in diagram, when it is in 1D, this is your car. Okay, this is your car. I don't know how to draw a car. Okay, this is your car. Your car is moving 80 km per hour. When it is positive, it will be going to the right. And when it is negative, it will be going to the left. Okay, so this is the idea. When you have a positive and negative value, it will automatically translate to direction. And when we are talking about direction, we are talking about a vector. Okay, and the other one is scalar. Okay, all right. So there are quite a number of physical quantity that we measure. So some that I can think of is speed and also velocity. And also, if you want to make it interesting, maybe you can try and guess what is the answer for this. Okay, I just show it down. Is energy, okay, is energy scalar or vector? Okay, which one is it? All right. Okay, so the answer for this one, if you think about it, energy, when we are talking about energy, energy doesn't actually have a specific direction. Okay, when you, let's say you are eating, you obtain energy, but there are no specific direction to where that energy go. Okay, the energy go to you, but then it don't really have any specific manner of which we can measure the direction. So in that particular order, we have energy to be a scalar. Okay, all right. Okay, next part is the last one for our introduction. Okay, this one if it might come in your paper 1 or it might come in your paper 2. Okay, but if this one come in your paper 2, then you should be able to answer this one. Okay, this one involves measurement. right? When we are talking about measurement, there are three main measuring device that you should know, which are meter ruler. Okay, this is a meter ruler. We have Vernier Caliper. This is a Vernier Caliper, and also micrometer, screw gauge. Okay, so what are the important things that you need to know about this thing? Okay, the important thing that you need to know is that they all measure length. Okay, they all measure length, but they measure length at different contexts. Okay, meter ruler you use to measure a very big object. You can use meter ruler. But if you are measuring using a vernier caliper is much more suited if you have object like this. Okay, this is a cup. Okay, I don't know if you can see. This is a cup. If you want to measure a cup, okay, what's the inner diameter or the outer diameter of a cup, then it's proper to use vernier caliper. Vernier caliper is more sensitive actually compared to meter ruler, because vernier caliper works in centimeter and millimeter range. Okay, and the most sensitive of all is micrometer screw gauge. Okay, so micrometer screw gauge, this one is used to measure a very thin object, such as as let's say you have a paper, you want to measure what is the thickness of your paper. There's no point of using vernier caliper, no point of using meter ruler, because they cannot actually give you any significant readings. Okay, vernier caliper might be useful, but then the most useful one to measure thickness is micrometer screw gauge. Okay, so I arranged them in the order of how more precise they are. Meter ruler, they are not very precise. Vernier caliper, they are quite precise, and micrometer screw gauge, this is the most precise. But can you use micrometer screw gauge to measure the diameter of a cup? Okay, you can, but it will be troublesome. So vernier caliper will be useful, more useful. Okay, all right. So understand how to read them and understand how they are used properly. Okay. All right, so now we are going to look at this. I'm going to just show you how to actually read a vernier caliper, just in case if you have never used vernier caliper before. All right. So this is a vernier caliper. Let me close the answer. Okay, so this is a vernier caliper. In order for you to measure using vernier caliper, you need to see where does the zero, okay, sorry, red is more proper. Okay, where does the zero stops? Okay, this is the first step. Okay, when you have a vernier caliper, you decide, okay, when you see a measuring on vernier caliper, you see where the zero stops. So the zero stops here. You are going to take this reading. This is 3. Okay, 3. And then this is point 1, 2, 3, 4. Okay, you have 3.4 over here. Okay, 3.4. Okay, 3.4 centimeter. And then over here, when you want to make reading using vernier caliper, check out which of these scale actually are in line to each other. Okay, which one are in line to each other? These are not in line, not in line, not in line, not in line. And you can see over here at 6, they are in line to each other. So you have 3.46. Okay, 3.46. This is, okay, the big reading. Okay, this one is the big reading. This one is in centimeter. So 3.46 centimeter. Okay. Or if you want to put it into millimeter, then 34.6 millimeter. That will be the proper answer for this one. Okay. Okay, let me minimize this back. Okay, so let's try this one. Another example. Sorry. Okay, so let me just zoom in. Okay. Oh, sorry, this one is not Vernier Caliper. This one is okay. Okay, so let's try and read this Vernier Caliper. This Vernier Caliper, it stops at 12. Okay, it stops at 12. You can see the 0 over here. So 12 centimeter, okay, 12.1 centimeter. So you should be able to see 12.1 centimeter. 12.1 centimeter. And then we are going to take the one that is parallel. So which one is parallel? This one is not parallel, not parallel, not parallel, not parallel. Okay, almost parallel, almost parallel. I think this one is the parallel one. 6, 6, or this one. Okay, let me check the answer first. Which one is more parallel? 6, 8 actually. Okay, 6, 2, 4, 6. Oh, this one. All right. Okay, the second part. Okay, so this one is more parallel compared to the other one. So we will take this one. Okay, so this is 6, 6, 8. So 12.68. Oh, sorry, 1 to 1, 6, 8. Okay, so the unit for this one is 12.168 centimeter. All right, so I get 12 over here. This is my big reading, 12 centimeter, and then I know that it stops at 1. Okay, it stops at 1, so 12.1 over here, 12.1, and then we take this measurement, get this one, 6, 8. Okay, 6, 8. So 12. Okay, 12.1, 6, 8. Okay, just take it one by one. Okay. Okay. All right. Minimize this. Okay, and for the final part, we have this one, micrometer screw gauge. To read micrometer screw gauge, this one is rather simple. You just look at this. We have from 0, the scale goes up to 5, and then 6, and then 7. So it should be 7 over here, 7. And then look at this scale now. This is 35, 36, 37, and 38. Okay, 38. So what is the measurement that we get? The measurement that we get is 7.38. Okay, and the unit is millimeter. Okay, and for this one we have, maybe I can zoom in. All right, so for this one we have 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so this is 7, but now our bottom part already exceeds this line. Okay, this line. So this is actually 7.5, not 7 anymore, 7.5. Okay, why 7.5? Because it already exceeds this line. Okay, and then this is 20, 21, 22. So 22. So you are going to have 7.5 plus 0.22. Okay, 7.5 plus 0.22. Okay, this is 7.72. Okay, 7.72 millimeter. All right. This one is rather useful when you are doing question 2. Okay, question 2 paper. This is very, very useful if you understand how vernier caliper and also micrometer screw gauge works. Okay, I believe you guys already know how to use a ruler, so I don't really need to introduce you with that. Okay, all right. So here are some sample questions that I have prepared. This one is based on past years. Okay, this is the actual question. And if you look at past years, each past year will have at least one question from chapter 1. Okay, this is the first one. Which quantity is base quantity? Potential difference, electric current, electric energy, electric power. Okay, this is the first one. From SPM 2014, question number 1. Okay, paper 1, question number 1. Which one is base quantity? Potential difference. Is it? Okay, potential difference, is it here? I don't think so. So this one is wrong. Electric current, yes. Okay, electric current is one of the basic quantity. Okay, and question number, okay, this one is also question number 1 in 2015. Which of the following SI unit is correct for each quantity? Mass, the unit is gram. Is it gram? SI unit for mass is not gram. SI unit for mass is kilogram. Okay, kilogram. And then time, minute. Is the SI unit for time minute? No, the SI unit for time is second. Okay. Length, is the SI unit for length in centimeter? No, the SI unit is in meter. All right. And the last one is Kelvin. We usually use degrees Celsius, but then actually the SI unit for temperature is Kelvin. So this one is correct. Okay. And for this one, which quantity is a vector quantity? Is mass a vector quantity? Does mass have any direction? Okay, we define vector quantity as one having direction. So is mass, does mass have any direction? No. Okay, mass doesn't have any direction. Does energy have any direction? Okay, I don't think so. I have mentioned this one just now. Energy doesn't have any direction. Does pressure have any direction or not? Okay. If you think about it, when you learn about pressure, you might learn that pressure, it acts on all surface. Okay, so you might incline to think that it have direction, but it actually not. Pressure just act on everywhere. Okay, if you somehow you stand over there, it will act on you in every direction. So it don't really have a particular direction. Okay, momentum, however, momentum do have a direction. If you are moving to the right, then if you are moving to the right, and then the object will have momentum to the right. If you are moving to the left, the object will have momentum to the, okay. All right, so those are the topics that I can cover for our first class. Okay, I know this one is quite simple, but even though this one is simple, don't take that as an excuse that you can just do it, you know, just like it is nothing. Okay, try to cover all of the chapters like you are actually going to go to SPM tomorrow. Okay, all right. So I have one more sample question with answer, but this one I will just let you try it. Okay, I already have prepared the answer also, so I will post this one on Facebook later. Okay, all right. Okay. Okay, so it's already 9. So our session right now, we are going to end our session now, and meanwhile we are going to have some video by our sponsors. Okay, video by our sponsors, and after the sponsors video end, if you have any question that you would like to ask either to me, or if you are interested to further studies at HELP, you might talk to the people from the department. Okay, all right. So okay, wait a minute. Okay, so let me get.
Have you ever thought of leaving Malaysia to explore the world? We're looking for explorers, just like you. Beyond Malaysia, there are many things we can explore, experience, and taste. And we want to help you do just that.
Hi, I'm James, studying biology in Imperial College London.
I'm studying economics at the University of Warwick.
I'm currently studying in the University of Western Australia with a Bachelor of Arts, majoring in psychology.
My name is John, and post A-levels at Health Institute, I went to Melbourne Uni and became a dentist.
I went on to qualify as a Chartered Accountant in the Institute of Chartered Accountants in England and Wales. I now work in renewable energy.
I'm doing my undergrad course in natural sciences at the University of Cambridge.
I went on to study medicine at the University of Aberdeen, and I'm now doing my final year of GP training.
One of the avenues is through education. Not only will you be able to have access to top universities around the world, but we will help you to achieve your dreams for much less. Why spend more? We can get up to a full scholarship in our A-levels program. All we need is your midterms, or trial SPM, or O-levels to secure a place with at least 1A and above. Hey, that's pretty easy to get the scholarship. Oh dear, look at the time. Click on the link above to apply, as we have limited spaces, and I will see you at Help Academy. And nobody deserves it more than you.
Okay, so I will let Mr. Sabah to take back the floor. Okay.
Thank you so much, Mr. Eilham, for your time and your effort. Okay, so we have one question. There's a student asked, "Sir, what is your Facebook username?" So just you share your username here so they can contact you directly, sir.
Mr. Raymond tagged me on the Facebook. You can view on the Facebook under physics link. Okay.
Yeah, students can join our private Facebook group and put questions there to any of our lecturers, including Engineer Eilham, and there will be a topic under physics that they can ask questions there.
Okay, so you can just join the Facebook group, and then my name is in one of the lecturers' name over there. Okay. All right. Okay.
Okay, so any more questions from the floor before we can end the session? There is a lot of thank you, Mr. Eilham, from the students.
Okay, all right.
Any more questions from the floor?
Okay, welcome. Okay. Okay, so I will see you guys next week, hopefully. Okay, this is just beginning, so hopefully we can cover all topics for SPM. Right?
Okay then. So thank you so much, Mr. Eilham, again for your time and effort. I'm sure most of us have already have a better view on the beginning of physics for our SPM revision. So before I end the session, I would just want to announce that the School Achievers Scholarship Award is now available here in Health University. It's also known as the SASA Award. We do highly encourage all Form 5 leavers to submit your application through our website. And there is a counselor on standby at the end of the session in case you have any inquiries on courses or with Health University itself. Okay, for more information, please log on to our webpage to find out more, or stay back after the session. We have an education counselor and standby to assist you again.
Okay, right.
Right,
Yeah.
so before ending the session, I would like to announce that tomorrow at 8 to 9 p.m. we do have a session on English. Alright, I repeat again, from 8 to 9 p.m. we do have a session on English. Please do join us in our Teams live as well. So thank you so much. Have a good night, good day ahead. Good luck for your SPM. Thank you, everybody.
All right.